Hi, ladies and gentlemen. Welcome to today's highly anticipated webinar on getting most out of the microservice architecture. How to ensure resilience and constant availability. I am Neeraj, and on behalf of entire team at WalkIntry, I extend a warm welcome to all of you. Before we commence, let's take a moment to welcome those who are still joining us. In case you are new to WalkIntry, let me introduce ourselves. At WalkIntry, we take pride in our relentless pursuit of technology driven innovations. Our expertise lies in designing and implementing cutting edge web and mobile applications across multiple platforms. We are not just a company, but a collective of visionaries dedicated to seamless system integration and driving a digital transformation initiative forwards. Our core competency revolves around advanced data integration, analytics, and modernizing legacy system onto high-performance platform. We offer comprehensive suite of business intelligence solution catering to various domains, empowering businesses with agility and efficiency. As we explore microservices architecture and how it may revolutionize your app, we set out a new and exciting journey. Through the webinar, we will look at the microservices benefits, including scalability, flexibility, deployment, and delivery. But we also talk about ways to deal with the difficulties like complexity, consistency, and communication, as well as resilient design for the fault tolerance. These tactics consist of load balancing, circuit breaker, error handling, failure designs, and monitoring. Our goal is to assist you in realizing the potential of the microservices and arm you with the knowledge necessary to successfully navigate the difficulties of creating distributed system so that you may create durable microservice application. Towards the end of the webinar, we have set off aside some time to address your question and insights. I encourage you to submit them in a question and answer box throughout the session. Let's harness the collective intelligence present here today to foster a more informed and engaging discussion. We eagerly await your active participation. So now let me introduce our esteemed speakers for today's session without any further ado. First, we have Naren, a senior technical lead with a decade of experience in expertise enterprise application development. He worked on different technologies in its conveyor and delivered complex projects without any complication, and with the satisfaction of the customer. His main focus was on microservices architecture, and he was extensive knowledge in the microservices designing patterns. He leads by the exemplifying the by focusing on building customer relations and ensuring that all the customer requirements are met while guiding his team to continuously improve in a timely and efficient manner. His valuable asset for WalkIntry in his ability to maintain a good understanding of customers. He is more focused on design and development of the resilient application that makes zero mistakes and less maintenance efforts in the productions. He is he is consistently enthusiastic and passionate about rapidly adapting to the new technologies. And meet Rishabh Suri, a seasoned technical lead specializing in end-to-end application delivery, guiding diverse teams through front-end, back-end, DevOps, and cloud technologies. Rishabh excellence in project success. His expertise shines in back-end development, mastering vital practices for robust microservices. With a strong grasp of resilient architecture, he is driving a force behind high performance software situations. He boasts a track record of leadership and technical excellence, committed to innovations and top tier results. He is an invaluable asset in any project, a true proficient in his field. So now I would like to hand over it to Rishabh. I hope you are doing great, Rishabh.
Hi, Neeraj. Thank you so much for the wonderful introduction. So, first of all, we are going to be talking about what is a microservice. We're going to be talking about its very basic understanding of a microservice. So, let's let's start by understanding that microservices is an architectural approach to designing and building applications as a collection of loosely coupled, independently deployable services. Each service, it focuses on a specific business functionality and communicates with others via well-defined APIs. This modular approach allows for greater flexibility and agility in development. Let's take an example. So Shopify, as you all know, it's a large e-commerce platform. In this platform, each microservice could represent a specific function, such as product management, order processing, and user authentication. These microservices, all of them collectively work together to provide a seamless shopping experience, allowing Shopify to evolve and scale independently. So now that we basically know what a microservice is, we are going to be talking about its characteristics. So decomposition is one of the most basic characteristic of a microservice. Microservices encourage breaking down applications into smaller, manageable components. This decomposition makes it easier to develop, test, and maintain each service. As at the same time, it also fosters a clear understanding of their functions. The second characteristic it has is loose coupling. Microservices are designed with minimal dependencies between them. This loose coupling enables each service to function independently and be updated without affecting others. It also allows for the use of different programming languages and technologies across services, aligning with their specific requirements. The third characteristic that we have is independently deployable. One of the core strengths of microservices is their independence in deployment. Each service can be developed, tested, and deployed independently of others. This flexibility accelerates development cycles and allows for continuous delivery of new features. Then we have single responsibility. Microservices adhere to the single responsibility principle, where each service focuses on a specific business capability. This ensures clarity in the code base and it simplifies the maintenance of individual services. Then we have continuous delivery. Microservices enable continuous delivery practices. Development teams can update and release services as soon as any new feature or fixes or patches are ready without having to wait for the entire application to be updated. Then we have the sixth point, which is isolation and security. Services are isolated from each other, both in terms of code and data. This isolation enhances security as breaches in one service do not necessarily impact others. Security protocols can be tailored to the unique requirements of each service. Again, taking Shopify as an example, the product management microservice handles product listings and updates, while order processing microservice focuses just on order fulfillment. These microservices can evolve independently, enabling faster feature development. Now that we have gone through some of the basic characteristics of a microservice, we're going to be talking about what advantages do microservices offer. The first one is scalability. Microservices can be scaled independently, allowing you to allocate resources where they are needed most. During high traffic events like sales or promotions, individual services can be quickly scaled up to handle increased demand. This elasticity ensures a seamless user experience without overloading the entire application. Then we have modular development. So development teams, as you know, can work on different services at the same time, accelerating the overall development process. Each team can individually focus on their assigned microservice, making it easier to manage and prioritize tasks. Then we have easier maintenance, which microservices provide us with. Individual services can be updated without impacting the entire application. This makes it easier to fix bugs, add new features, and so on. Apply security patches as well to specific services. Maintenance tasks are more focused and efficient. Then we have technology heterogeneity. Microservices, they allow for the use of different technologies and programming languages across services based on their specific requirements. This flexibility means you can choose the best tool for each job, resulting in optimized performance and development. Then we have resilience. It's one of the key advantages of microservices is their inherent resilience. Faults in one microservice, such as service outage or performance degradation, do not necessarily affect others. This isolation, it minimizes the blast radius of issues and enhances the overall stability of the system. Then we have autonomous teams. Microservices encourage the formation of autonomous teams responsible for specific services. These teams have ownership over their respective microservices, fostering innovation and accountability. They can make decisions independently, leading to faster development cycles and more tailored solutions. Again, taking Shopify as an example, its development team can enhance the user interface of the microservice while the inventory management microservice, it continues to operate without disruption. And considering the advantages it has, there are some shortcomings also of the microservice architecture. So we'll just go through a few of them. The first one is distributed complexity. When there is a network of interconnected services, it requires proper orchestration and monitoring to avoid complexity issues. As services communicate with each other over networks, there's a need for effective service discovery and orchestration mechanisms. Then we have service coordination. Services need to communicate effectively, often involving network calls, which can introduce latency and failures. This coordination requires careful design, and developers must consider issues like timeouts, retries, and load balancing. Then another major shortcoming of the microservices is data management. Ensuring data consistency across services can be challenging. It requires careful design and synchronization mechanisms. For example, Shopify must ensure that product availability and pricing, both of them are consistent across multiple microservices to prevent discrepancies in shopping experience. Then another one which we have is service discovery. Locating and connecting to different services dynamically, it can be complex. Service discovery tools and practices are crucial to managing this dynamic environment. Then we have network latency and failure. Communication between services can be impacted by network issues. Shopify's services must be designed to handle network latency and occasional failures gracefully. One of the last shortcomings is security and authentication. Maintaining security across various services can be integrate. Each service must implement robust authentication and authorization mechanisms to ensure that only authorized users and services can access sensitive data or functions. For example, we'll take an example of all the challenges which they come with, ensuring that order processing, payment, and inventory management services in Shopify work harmoniously during high traffic events like during a sale. These are pretty complex challenges to deal with. So yes, we have covered some of the challenges as well. Now I'll hand it over to my colleague Narendra, who is going to be talking about how to build resilient microservices and the strategies for the same. Over to you, Narendra.
Yeah, thanks, Rishabh, for elaborating us about the microservice challenges and advantages. Hi, good evening. Thanks for joining the session. Hope everyone doing good. Let me share my screen. So I hope you can see my screen, right? Earlier days we can see that we can see the monolithic applications like with a big application and a big code base, and we have seen a lot of challenges like even if you understand if a new person has joined in your organization to understand that code or to fix the bug, it will take huge time. Then nowadays we are migrated to microservices, but with microservices also we have some complexities as Rishabh explained. So everyone knows, I hope, microservices are in distributed nature. So when your application is in distributed distributed, so we can't predict where can a failure will occur. So there will be a chance of service unavailability or network failure or slowness of the application or net like a broken pipe or out of memory. There are different kind of errors will come. So if you don't address those in your design, then definitely our application will fall down in the production environment. So in order to avoid all this situation, even this kind of situation you come in the production, but your application has to be working with a limited functionality. So for this one, we need to take some considerations in our architecture. So the general meaning of a resilient is nothing but how quickly you come from your failure. So similarly, resilient application is nothing but how quickly your application respond back from a failure. So that is the resilient application. So what are the how we can say a application is a resilient? So if your application has the following characteristics, then we can say the application is a resilient. The first characteristics of the resilient application is the fault tolerance. So that means if any failures happen in the hardware or software, still if your application able to sustain and it able to serve the users, then we can say your application has a fault tolerance. And coming to self-healing, let's say whenever you get some out of memory or some resource crunches or some kind of errors, your system has to automatically detect and it has to be solved with a minimal human intervention and reduce with a minimal downtime. Now coming to scalability, nowadays we can't predict how much load will be come to your application suddenly. Like let's say if you take an e-commerce application, when you are giving a like offers at the time, you can see the too much of load. At that time, user should not feel the application is not working kind of thing. So you should maintain and you should consider all the scalability, auto scaling in your in your application design. So the next characteristic is the graceful degradation. So whenever some failure happened, your application will work as a limited functionality. But even it is working as a limited functionality, user should not feel like application is not working or it's a limited functionality is working. So you need to utilize the catchy data or some proper way based on your use case. So user experience should be the it should be good. Otherwise, user will feel like application is not working. Now the next characteristic is the monitoring and recovery. So in order to identify the issues early and to fix that, we need to analyze our logs and all. And you should have for that, you should have good monitoring system and alert management you can use. And coming to dead recovery, so as a we can't know when the application will be goes down in the production, so you should have a better disaster recovery plan in your application. So these are the main characteristics of the resilient. So whenever your application have these all these things, so we can say that your application is a resilient. Now coming to the resilient application implementation. So there are different libraries are there in resilient to implement the resilient in our microservices, like Netflix Strix. We have Resilience 4J, but Netflix Strix is not in a maintainable state. And this Resilience 4J is taken from this Netflix Strix, and it has the good support from the forum. So Resilience 4J will not only support the Spring Boot, it will support other microservice frameworks like Drop Wizard, Vertex, and all. So in this one, we have a different patterns we have to implement the resilient, but I'm going to cover the most important patterns what we need to use in our application to become a resilient. So first one is the circuit breaker pattern, retry pattern, then timeout pattern, then bulk head pattern. We have a rate limited pattern. So the next one is circuit breaker pattern. Circuit breaker pattern, like it will work as a electrical circuit breaker. How electrical circuit breaker will protect us from the power failures. So basically, when let's say you have a two services, let's say product service and rating services in e-commerce application. So when user comes, suddenly rating service is not working, but continuously product service calling to the rating service. Either service unavailability or some issue in the rating service So it's not working. So at that time, let's say product service trying to call multiple times and all threads will hang with that, and product service also will go down because of the dependent service failure. So in order to avoid such cascade failures, we can use the circuit breaker pattern. Basically, circuit breaker pattern will has the three states. The by default state is closed state. That means the dependent service allow the connections to the calls to that service. And whenever your let's say you have a 100, you configured as a 100 as your request and threshold as a system, means out of 100 requests, if 60 requests are failed, then the circuit breaker will enable and it's enter into open state. In the open state, it don't allow any network calls to your service. So after some certain time, it will enter into the off open state. In the off open state, you can allow some of the network calls to your service, and if that is working fine, then automatically the circuit breaker will enter in the closed state. Then it will allow all the network calls to your service. So that is the circuit breaker pattern. Now coming to the circuit breaker pattern implementation. So with this resilience 4J, it's very easy to implement this one. So basically, you need to mention the configs, basic configuration of the your circuit breaker in the application.properties. And the circuit breaker pattern we can implement two different ways. One is count based or time based. In the you can see here, sliding window type is count based. That means we have given a sliding window size as 100. Means out of 100 requests, we have given a failure rate threshold as a 60. That means out of 100 requests, if 60 records are failed, then the circuit breaker will enter into open state and it don't allow any calls to the dependent service. So other important configurations are how many number of calls you can permit in the off open state you can configure, and how much time it can stay in the open state. It will be in the seconds. And how it can treat that error as a failure. It cannot treat all the errors as a failure, right? Let's say you have a bad request, that is not a system issue, that is either some user data issue or something. So and those kind of issues we can avoid. So we need to give that exception is here as a recorded exception. So record whatever exception here give, it will that exception and inherited exception it treat as a it will treat as a failures. So along with this configuration, you need to annotation whenever you are calling your dependent service like HTTP client calls to that one. You need to annotate that method with the circuit breaker, and you need to provide the name of this configuration along with the default method. Like whenever any failure occurs, what it has to do. In that method, you can implement either catchy data or you can return a empty data. So this is how we can implement a circuit breaker pattern. So with this circuit breaker, you can reduce the cascading failures, the issues from downstream to upstream, and you can make sure the application is working with a limited functionality. Even some services went down. That is the advantage of circuit breaker. And now I'm moving to the next pattern. So retry pattern. So the name itself it's mentioning a retry. So whenever your application is a slow, some service in one of the service, some of the API is responding very slow. So at that time you can give a try, one more try until your dependent service respond back. So in this pattern you can see you with a fixed delay you can call multiple times the dependent service API. So now coming to the implementation of retry pattern, you need to give how many retry attempts you can give and what is the wait duration in between the each attempt. So now coming to here retry exception, you can see. So what kind of exception you want to apply this retry pattern, and what kind of ignore exceptions you can ignore this pattern. So for all kind of exception, we can't apply this pattern. So whatever like HTTP server error exception, you can give a try, but you cannot give a try for the other kind of exception, like as I mentioned, bad request or HTTP client error exception kind of thing. So this is but with this retry pattern, you should more careful about your configuration. Don't give more attempts and more wait duration, because if you give more attempts and so it will keep a load on your network and it will reduce your net latency. and it will block your threads also. Okay, so that is the retry pattern. Now I'm going to the next pattern. So timeout pattern. So timeout pattern is basically when you have a two microservices and one of the microservice, like even same thing. If your application is slow and you want to timeout if it is taking more time with some threshold value. Okay, at that time you can apply the timeout pattern. So in this pattern, coming to the implementation, we need to give the how much timeout duration. If you can give the either if it is a running toss or there, you can cancel or you can continue all those. So with this timeout pattern, so basically we are what are the advantage of this timeout pattern is we are unblocking the long waited threads. Let's say if some of the things are taking too much time or long running queries are taking and it's not giving response, those kind of things you are closing within a time, and you are making service availability more, and it will serve the more requests. This is the advantage of the timeout pattern. Now coming to the next pattern, bulkhead pattern. So the main advantage of the bulkhead pattern, basically bulkhead pattern will deals with the to use the resources effectively by reducing the resource crunch. Let's say you have a let's say your service has a 10 threads, and out of 10 threads, let's say your service is calling another service, and that service has a some it is taking more time, and it has a some CPU related, like it will take more time to calculate, and let's say for example tax calculator, or if you are purchasing something, so you need to find out what is the price after the uh, after applying all the logic. So this kind of things, like in this case, maybe your service will allocate all the resources to that particular API. Maybe the other APIs in that service, maybe they will not get threads to serve the request. So in order to avoid that situations and better utilization of the resources, so we can apply the bulkhead pattern. So now coming to the implementation part, bulkhead pattern configuration. So you can configure like how many max concurrent calls you can allow in the system to call the dependent service or reverse service, so that it will only allow those kind of those number of concurrent calls to the dependent service. So remaining threads you can use for the other requests. That's how you can avoid the resource crunch. So the next pattern is the rate limited pattern. So basically, circuit design pattern will save our client like a caller service, even if your callee service is failed. But coming to rate limited pattern, you can make your caller service highly available by limiting the your throw output. Means you can say like this service can handle this many requests within this time. Other than that, it don't handle. So by limiting this throughput, you can say you can make your service highly available and save from the failures. So coming to the rate limiter pattern configuration. So it's very simple. You can give the within a period how many calls you can allow to make a call. So here you can, I have given a sample thing, 60 seconds. Out of 60 seconds, you can only allow the 5 calls to the service. This configuration you can apply at service level or the method level also. So this is the advantage. The main, as I mentioned, the main advantage of rate limiter is so it will make sure your service is highly available, and it will reduce the like failure of your service. Now, okay. Apart from these patterns, we have other patterns also, like Saga pattern. Saga pattern, like in our microservice application, as per the basic principle, each microservice should have its own database. So our in distribution application, each microservice will have its own database. So data consistency is required in our application. So in order to achieve this data consistency, we can use the Saga pattern. So Saga pattern is nothing but a group of local transaction that together form a global transaction. let's say you are purchasing in e-commerce application, you are placing an order. You are placing an order means it has to create an order, it has to update your inventory, and it has to do the payment. If any one of them is failed, it has to roll back all the transaction. With this, we will achieve the data consistency in the distributed application. So again, in the Saga pattern, we have a different different ways we have to implement that, like a choreography pattern, orchestration pattern. So orchestration pattern is a centralized one. Like in orchestration pattern, only one microservice will work as a service coordinator, and it will issues the commands to the next services. Like let's say whenever order is created, it will issue the command to inventory system to update the inventory. Then if it is any failure occurs, inventory will produce a event to the this one order service kind of thing. So that is the orchestration style. And there is another one, choreography saga pattern. In choreography saga pattern, it's a decentralized one. Choreography saga pattern is a decentralized one. That means there is no like a single microservice will not take a responsibility. It will distribute it in multiple microservices by using the event emitting. So you can send a event. So once your service is you first transaction is done, then you can emit a corresponding event. Then whoever consuming that event, and they that will consume, and they will that will send, that will again produce another event. With this one, it's a loosely coupled transactions. So if you want real time data consistency, you can go with the orchestration pattern. Or if you don't need a real time consistency in your data, that means immediately uh, data you don't need in your application, like in the UI you don't want to show. Let's say for example, if you take any let's say government municipality applications, where you can just you will take your complaint and you will just give a acknowledgement number. So in that cases, we don't need a real-time consistency, so that we can use the choreography pattern. But otherwise, when you need a real-time data, then you can go with the orchestration pattern. So apart from the saga pattern, we have another pattern. We have the API gateway pattern. So API gateway pattern also, it's a redirect all your client requests to different microservices. And with the API gateway pattern, if you use API gateway pattern, there is a lot of advantages are there. Kind of like you can do the cross functionalities, cross cutting functionalities, like logging and authentication, authorization. Like if you want to request aggregation, like if you call the multiple services, and if you want combine the response to a single as a single response, or if you want to trace the your distributed application, you can add the headers like a correlation ID or something. And if you want to enhance the headers, all you can do the in our API gateway. Not only this one, you can do the service discovery or load balancing, all this one in the API gateway. So these are the advantages with the API gateway pattern. And there is another pattern. One of the pattern is another pattern. My latest pattern was the service mesh. So service mesh pattern basically involved in the inter-service communication, as in the distributed application architecture. I think each service will interact with each one, right? So in this case, with the service mesh, whole service mesh will help us all the load balancing and service discovery, all the logging, whatever till now we discussed, all the things you can do using the service mesh at single place. Either if you are using the ingress control as a load balancer, then you can do it at a ingress level, or you can do at a API gateway level instead of doing in the all the services. So you can apply all these patterns at a single place by using the service mesh. So you can based on your use cases, you can apply the combination of the this pattern also. So these are the design patterns which are mostly important design patterns we need to consider when you are designing a architecture or application architecture. The next one is the scalability. As I mentioned earlier, so scalability is one of the characteristics of the resilient application. So nowadays I think these microservice architecture applications are good for this one containerization. So everyone is using the Docker containerized applications. So along with the Docker containerizer applications, we are using the orchestration tools kind of Docker Spam or the Kubernetes to deploy and all. So with this one, the scalability will become very easy. You need to just provide your infra, and based on that, like a load, it will automatically scale your instances. So scalability we can do in the two ways, either horizontal scaling or vertical scaling. So horizontal scaling, in the horizontal scaling means you can increase the number of instances whenever load occurs. Or vertical scaling means you can provision the more CPU and memory to your existing instances. With this scalability, whenever some load occurs, your service will not go down, and it will automatically serve all the load on the system. And the next one is the load balancer. I hope load balancing will distribute your traffic to different instances. So with this one, client will not directly communicate with your services, and your service availability will be increasing. This is about scalability and load balancing. And the next point is the monitoring and observability. So why we need a monitoring and observability in our microservice application? So monitoring, as I mentioned earlier, if you want to upfront, if you want to know the issue, so you can use the monitoring. So basically, you can use the ELK or EFK, and you can configure different 500 errors, or you can configure which API is taking more time. You can analyze all. You can analyze through your monitoring tool. And coming to observability, when your application is distributed in nature, so the transaction will happen in many services, and you need to identify like which service is taking how much time. All this observability you can get it from the you need to know. So for this one, you can use the one of the tool like Agar, which will internally it will use the open telemetry to get the all this data. So this is the what we need to have in our system to identify the earlier issues before the customer informing the issues or services going down. So this is about monitoring and observability. And along with this monitoring and observability, the deployment strategies, different deployment strategies also make your application highly available. Like in deployment strategies, we have a different kind of approaches, like a blue-green deployment. In a blue-green deployment, your blue environment will be the old application, like old version it will have, and whenever you want to deploy a new version, you will deploy to green environment in another environment. And with this one, once you tested and customer like feel it's working fine without any bugs, then you can simply you can change the load balancer to this environment. But the disadvantage is you need to maintain a different environments for this one. It's a cost. I think it's not a cost effective solution. And another one is the canary deployment strategy. So canary deployment strategy is one of the thing, like you can distribute the latest feature to some set of users, so they can use and they can give the feedback. Based on that, you can slowly migrate to the other users also. So that is one of the deployment strategy. Along with the canary deployment strategy, we have the rollback, how quickly you can roll back your services or roll forward. Let's say if there is any data instances, how can you quickly fix and you can roll forward the your you can roll forward the latest version. So these are the different deployment strategies. Well, like other deployment strategies also, we have like A by B testing kind of thing. So with this deployment strategy, we can make your application highly available. So that's it all today. I hope everyone has some idea how can we implement the resilient application. So now we can take a questions if you have anyone.
Thank you, Naren. Thank you, Rishabh. There are few questions. So, how microservice architecture help offering decoupled solution package under SaaS platforms?
Okay, so I'll take that one again.
Yeah, go ahead.
So actually, uh, what microservices offer are like It offers continuous improvement and modularity and scalability. So because of these offerings itself, it provides these offerings which it provides, you know, it allows seamless integration of diverse technologies and rapid development, ensuring independently scalable components in SaaS platforms. So in this manner, it fosters customization and agility as well. So yes, that's how it happens.
Okay. So there are few more questions. So from Sandra, can microservice architecture make any significant difference to decentralized app or DApps?
Well, yes, totally. Microservice architecture can make a significant difference in the context of, decentralized applications, dApps, as you said. So by breaking down dApps into microservices, they become more maintainable and adaptable, fostering improved user experiences, and it allows easier upgrades in decentralized ecosystems as well. So, yeah,
Along
that's
with the Rishabh answer, I just want to add. So basically, DApp kind of apps like blockchain using Ethereum. The main issues we'll see is the scalability and data management. So basically, the one thing is microservices is just one orchestral style. It's a small part. Just you are decomposing your application into multiple services based on your functionality. But how it will avoid the scalability and data consistency issues are how you are designing your architecture. It's not only microservices. You need to implement other things also in our application to take the this to provide the scalability and to solve the data consistency issues.
Okay. So one more question from Sean Taylor. Is microservice architecture fits well with the super apps, the kind of app that combines with multiple apps together?
Naren, would you like to answer this one?
Yes, super app means it's a combination of multiple apps basically. So that multiple apps you can separate into modularization, different modules, so that your maintenance and your maintenance cost also it will reduce. So that's how it will help us in the super apps.
Okay. So one more. Which of these pattern would be the applicable to the to Node.js and AWS environments, and why?
Yeah, AWS has a different services, kind of AWS Lambda, AWS serverless application architecture we have. So which will always take care about the high availability and resilience in the your application. So you can, if you want, you can apply this one. Already API gateway, AWS API gateway is there, one of the service. It will take the load balancing and it will forward your request to the your services, different microservices.
Okay. So that's all the questions from the participants. And thank you all the speakers to share your valuable insight. And thank you everyone for joining us today. I hope you found today's webinar valuable. Before we signing off for the today, I wanted to let us you all know that we having a interesting lineup of webinar next month. On 28th of August, we have a very insightful on LLM and data visualization, which enhance your product engineering insight. We'll be sending you invite to you all. Until next time, folks, thank you once again for joining us today. Thank you all.
Thank you all. Have a nice day. Bye.
Thank you, everyone.